When you are doing negative powers and reciprocals, remember the negative power means to do the reciprocal. So that'd be 1 over 2 cubed. A normal power though has to be treated as a normal power, so we'd still do 2 times 2 times 2. We get our value of 8 on the denominator there. For the reciprocal of a decimal or any number, just write it as 1 over, and then if you've got a calculator, you can always use that to simplify an answer to a decimal, as we're not allowed decimals in fractions. For highest common factor, make sure you know the word factor, so we're going to be writing down the numbers that go into 72 and 90. Draw yourself a nice neat table, write down the factors of the easier number first, and then just test to see which of those numbers go into 90. So once you've got all of your factors, start with the highest and work your way down your list and figure out what that highest common factor is that goes into both of them. For standard form, you need to know how to convert. So converting large numbers, we'll count the decimals till it's between 1 and 10, and then just count the jumps so you know what power of 10 that's going to be. So for this one, we can count those jumps, and that comes out as a power of 7. For a smaller number, we just need to have a look at that carefully, again writing it between 1 and 10, and then when we count the jumps this time, we know that that power is going to be a negative for a 0-point number. So this was negative 5. When converting back the other way, write the actual number itself, so 3.42, imagine where that decimal is, and then hop it whichever direction we need to. So for a positive power, we'll hop to the right. Any loops that are unfilled, stick the zeros in and rewrite your number nice and clearly. We do exactly the same when we've got a negative power. Write the number, but with this time with a negative power, we're going to be hopping the other way. So hop to the left, and again, tidy that up by putting zeros underneath your loops and at the start, and rewriting your number so that it's really nice and clear. When you have calculations, you can apply some tricks, but we need to multiply those first too. So for this one, use your multiplying decimals method to get your answer unless you have a calculator, and then you can add the powers when timesing or subtract when you're dividing. If your answer is not in standard form, you will have to balance that out, so making the number smaller makes the power bigger, and then of course if you're asked to write it as an ordinary number, you can convert it back. When you are working out a percentage of an amount, always start by working out 10%. So write down what 10% is by dividing by 10. From there you can halve it if you need a 5%, and then you can make any combination. So for 15% we just need to add those two together, and that would give us our total there, just making sure we put any units if we need to. If we have a longer question, read it nice and carefully and highlight key information. For an increase, we can work out 1% by dividing 10% by 10 again, and then we can get any percentage there. So 3% would be 3 lots of that, and if this is a percentage increase, we would add that on to find that amount after an increase. If we have a larger question where we're looking at percentage profit, work out anything you can. So for this question, we can work out the total cost of these 12 bottles. From there you can work out a profit and use a profit formula. So profit or change over original multiplied by 100 would convert that into a percentage for us. And if it says to give your answer to 1 decimal place, you can round that at the end once you've written down your final bits of working. When you have to do error intervals, make sure you read it carefully. It can help to draw a number line and obviously know how your answer is written. So if you were to draw a number line for this one, we know that 4.75 and 4.77 are either side, and we are looking at the midpoints. So those midpoints are our lower bound and our upper bound, and we just stick those into our error interval to show that that's what the number would be between. If you have a truncation question where it doesn't talk about rounding, these are a little trickier, but they are really nice and quick to answer. So when you are doing this, the smallest answer is the one that you can see, and the largest answer is the next decimal up that it couldn't be. So there we go, there is some truncation. Okay, moving on to algebra. When collecting like terms, we can use any method that is going to help us to visualise that. I like to box off some of the letters and combine those first, and then circle the other ones and combine them, and not forgetting that the number 1 goes before any letters. When we have powers involved, don't forget again there is numbers in front of them, but we just combine and collect and say how many there are. We are not going to add the powers as we are not multiplying for that type of question. When we are multiplying though, we can multiply any numbers in the question, and any letters can just be written next to each other without the time sign. When it comes to multiplying and we have powers involved, this is where the power increases. So for this, where we have powers of 1, we'd add all of those powers together, and that'd be y to the power of 3. So just being careful not to get confused between adding and multiplying. When we are looking to substitute, we may have positive and negative values, just put them into the places where they are in the question, and then make sure you remember that 7r would mean 7 times r, and 3q would mean 3 times q, and being careful for any positives and negatives in a question. If you have something slightly harder where you have powers, obviously if you don't have the value, figure it out, but we can sub the value in, and not forgetting that the 2x squared in this question would mean 2 times x squared, so we'd have to do the power first and then multiply. So we wouldn't want to do 2 times 3 and then square it. If you have a formula, just read the question carefully and make sure you sub any numbers into the positions where it's asked you. Don't be put off by all of the words in a question, you just need to sub it in and work it out as you would if it just said the formula without all of the words. If you have to work backwards, again just read the question carefully, and you're trying to figure out what that missing piece is. So you can use trial and error, or you could reverse it like an equation like the one on the screen here. And again, if you need to, don't forget you can pause this at any time. With laws of indices, when you are multiplying, just like before, you can add the powers. So we would add the powers here. 3 plus 4 would be a power of 7. When you have brackets, you have to multiply the powers, and that includes any numbers within the brackets. So 5 to the power of 1 would become 5 to the power of 3 in this question, and all of the powers would multiply by 3. Again, we need to make sure we simplify any numbers and write them as actual numbers, not powers. When dividing, you divide the numbers and subtract the powers, and again not forgetting to put in any secret powers of 1 there that are not written in the question. If you have something slightly harder like this, don't forget you need to tidy up the top first by adding those powers and being careful with negatives, and then you can focus on the division if it is written as a fraction. If it says write it as a power of 3, then we could leave it as 3 squared like this, but if it wants a value, you have to write the actual number of that power. When expanding brackets, make sure you multiply what's in the bracket by what's outside. If there's any letters, don't forget that's going to increase the power like we've just discussed with our index rules, and make sure you multiply both of them by whatever's on the outside. If you have two sets of brackets, be particularly careful if there's a negative in the middle, because this means after we expand the first one, the second one is actually being multiplied by -2, so that is going to change the signs on both of them. Again, then use our collecting like terms method and just be very careful to add and subtract any pieces, being careful for those positives and negatives. If you have to expand double brackets, remember you have 4 multiplications to do. So start by multiplying them both by the first piece in the first bracket, and then multiply the second bracket by that second piece, and again we are going to simplify those middle 2 pieces, again being careful of our positives and negatives. If you have coefficients higher than 1, don't let that put you off. You just need to incorporate the number in front of the letter, but following the exact same process that we have above. Again, getting those middle 2 pieces and simplifying them to write to your final quadratic expression. If you have to factorise, don't forget we're just looking to think what factor goes into both of them, and we put them on the outside of the bracket. So for this one it's 3, and then just reverse the expanding process. So 3 times n and 3 times 4 would give us the 3n plus 12. If you have to factorise fully, you tend to have a letter that goes out as well. So look what's in both, take it on the outside, and then again just reverse the process when we were expanding. When factorising a quadratic, just make sure you write down the 2 factors or the pairs of factors that multiply to make the number at the end. Recognise that that's a double bracket, and then we just need to spot the 2 numbers that add to make 6 in the middle. So this would be 3 and 3, and just put those symbols in and they can go in either order. If you have to change the subject, we are just reversing a process, doing the inverse of what's happening. So for here we need to take away the 4, then we would need to divide by 2, and x would be on its own, and that's what we mean by making the subject. If you have a square root, you're going to have to square to reverse that, and then again, if you have a fraction, you have to unlock the bottom by multiplying by that denominator. You can then finish that off by finishing any inverse operations that you need to figure out. If you have to solve equations and there's brackets involved, we will need to expand those brackets first. Again, then we'll be doing the inverse, so adding 20 for this one when it says -20, and then dividing by 4 if it's 4 lots of x. If you have equations with an unknown on both sides and brackets, again we'd need to get rid of the brackets, but once we have done that we can be solving it in the same way. So we'll expand the bracket and then delete the smallest x from both sides. So for here that's the 3x, not forgetting to include any symbols with any pieces left over. Again, following the same process, we could add 6 to both sides and divide by 2 to get a final answer, and we can write that as a fraction or as a decimal. If you're solving a quadratic, we need to factorise this like we were just a moment ago. So write the factor pairs, get the correct pairs here that add to make 5, and then when you solve it, all you do is look at those numbers in the brackets and flip the symbols and you will have 2 answers. So there you go, really nice and simple on that final step. If you have to write any expressions or formulas, read the question really carefully. It'll tell you that one person is a particular letter and then give you some instructions about the others. So Chloe is twice as old would be 2n, Dan is 5 years younger than Ben. So here we would take away 5 from Ben and we would have all of our expressions. It does say here the total age is t years, write a formula, so t equals the total, and the total of those 3 expressions is 4n minus 5. For slightly harder forming and solving equations, know your shape facts. So for this one, opposite sides in a rectangle are equal, so we can make an equation with unknowns on both sides as well. And from there you can solve that like we've already discussed, and potentially have to use that to figure out any side lengths by substituting it back into those lengths in order to answer potentially a slightly more complex question, but just reading them carefully. If you have to solve simultaneous equations, I tend to always make the coefficients of y the same. So for this one I have multiplied the top by 4, there are other ways to go about it, but once you have those coefficients the same, different signs add, same signs subtract. You will then get an equation for x, which should be hopefully relatively simple to solve, although it may create fractions or even negative fractions. Don't let this put you off though, get your value, and even if it doesn't look particularly nice, substitute it back into one of the equations to find your value of y. As long as you follow those steps, you are definitely going to be picking up method marks, even if the values of x and y are slightly complicated. And they can be with simultaneous equations. When looking at inequalities, you need to know how to draw on a number line. Remember just to put a circle above the numbers in the inequality and point it the direction, whether it's smaller or greater than. If there is an extra symbol on that inequality, you may need to colour it in, but otherwise you don't need to. Integers between two values, don't forget that if you do have that extra line, it will include that number, and if it's not equal to as well, it won't. When you are writing a double inequality like this, make sure you put the numbers that are related to the two numbers on the number line with your arrows. Any that are coloured in will need an additional line underneath it to show that it's equal to, and then you just put the numbers there. And now remember, this could be done in either way, so you could actually have to draw them as well. If you have anything in the middle of the inequality, you're going to have to do the inverse to both sides before you can actually go about drawing that. So for here, where there's a plus 3 in the middle, we take away 3 from both sides, and then we would draw the number line just like we have done in reverse. So putting the circles above those numbers, then we would go about colouring in any of them that have the additional line on, and there we go, we would have our number line drawn. If you have any picture patterns in your sequence, you may be asked to draw them, but otherwise we're going to turn them into numbers. Treat that the same way as the number sequence, find the difference between them, that'll tell you what number goes in front of n, and then compare it to that times table. So this one is 1 bigger than the 3 times table, so it's 3n plus 1. You may be asked to use that as well, you might be asked to substitute into it or see if they fit into a particular pattern, but for this one here you'd solve the equation and see if it's a whole number. When looking at coordinates, make sure you know that you are plotting the x-coordinate along the x-axis and the y-coordinate up and down on the y-axis, so find your points really carefully and make sure you can read them and write them. If you're asked to mark them, make sure you put any letters with that, so this one has asked us to mark 2, 3, and then also drawing the equation of a line. X equals lines will go up and down through the x-coordinate that it relates to, y equals lines will be going horizontally through the y-coordinate. If you're asked to draw a straight line graph, you may be given a table. If you're not, you need to draw that table yourself. Look at what x values you need. If it doesn't tell you, look at the x-axis, and then just substitute each value into your y equals equation that you have in order to find all of those y coordinates. Once you've done a couple, you can spot a pattern, and then once you've filled in the rest of the pattern, you can go about plotting those coordinates on your graph and making sure you read the scale and join up your points with a nice straight line using a ruler and pencil. That's how you're going to go about drawing any of these graphs. When looking at a cubic graph, you'd follow the same process. A cubic does have a different shape, but you can use table mode on your calculator, which may be helpful. Anyway, you can fill them in using the same process, so just subbing those numbers into the equation and then drawing it nice and neatly with a nice smooth curve. If it's non-calculator, be very careful with your substitution. For a reciprocal graph, you are going to have sometimes some quite nasty divisions to do, but the majority of the time they're relatively easy to figure out. Just substitute those x values into the equation and get them all in as best as you can. Again, plot the points very carefully and we would join it up with a nice smooth curve, and this is what our reciprocal graph looks like. Again, most of these are done with nice smooth curves. You may have to identify graphs, so you need to know the reciprocals, cubics and quadratics very well. Here we have a reciprocal, 2 cubics and a quadratic, and that one in graph B is a negative cubic. So you need to know not just the positive versions of the graph, but also the negative versions. So just make sure you're really confident with what they look like and you know the shapes that they are going to create. Okay, on to Pythagoras and trigonometry. Anyway, with SOHCAHTOA, you could be asked to find a side or an angle. So you need to know how to label the sides. Opposite the angle is the opposite, the longest length is the hypotenuse. Only label the 2 sides you need and then pick your formula. So this would be sine. To find the opposite, we would cover up the O and do S times H. And when you type that into your calculator and you type sine, don't forget it will open up the bracket to remind you where to put the angle. You can then multiply it by whatever the hypotenuse is or whichever piece we are using in that particular formula. When finding an angle, you will need to again label the sides. So for this particular one, we have the hypotenuse and the adjacent. So that would be our cos formula triangle. And when finding an angle, we have to press shift before sin, cos or tan, just to tell the calculator that we are looking for an angle. So for this one, we would press shift and then cos, and then type in the adjacent over the hypotenuse, and again rounding our answer to whatever amount of degrees or decimal places we have been asked to in the question. Okay, so moving on to statistics. So when you're looking at particular averages, you need to remember that in order to find the median, you need to put them in order of size. From there, you can cross off numbers from either end, helping you to find what's in the middle. When you're looking at the range, you need to do the biggest, take away the smallest, and when you're looking at the mean, you need to add them all together and divide by how many numbers there are in order to find that mean average. For when you are looking at reverse means, you need to actually multiply the amount by the mean that's given. So for this one, the whole class is 60 and there are 30 students in the class. So the mean multiplied by 30 gives us the total. We would apply that to any other statements that are given about the means, and then we can also find missing totals that we need and find the mean as normal. So for here there was 720 as the total for the boys and 10 boys, so we could do that as a division. When you have a scatter graph, you may have an outlier involved. An outlier lies away from the line of best fit. You may be asked to give the coordinates of that. So you might also want to think about reasons why an outlier could exist. When you are using a line of best fit, you're going to want to draw a line of best fit. If it's sloping up, it's a positive correlation. If it's sloping down, it's a negative correlation. And if you're asked to read from that line of best fit, go across to your line of best fit carefully and make sure you read the scale accurately. For a frequency polygon, it's a really nice easy one to draw. You just have to get the midpoints, plot them against the frequency, and then just join them up dot to dot from the start to the end. You just need to make sure that you don't join it up to the axes or the origin, you're just joining it dot to dot with a ruler from the left to the right. You may be asked to find things like the modal or the median class. So for the modal, it would be the most common, and for the median, you just have to count down cumulatively to find where the middle one is. For a pie chart, you do have to make sure all the numbers add up to 360, so see what they add up to and how we would get them to get to that total. So 120, we would want to multiply them all by 3 to get a total of 360. From there you can write down what all the angles are, and then you just need to get your protractor out and make sure that you measure it really nice and accurately. Make sure once you've done that you label all the pieces. When you are looking at sampling and bias, have a look at how big the sample size is. This one is out of 30, and it's asking us how many want to go to the theme park. So to the theme park would be 10 out of 30, which is the fraction 1/3. So if there's 195 in total, that would be 1/3 of 195, or whatever fraction of an amount we are given, and the assumptions we would make is that the sample represents the rest of the students. On to ratio and proportion. For larger worded questions, particularly these with fractions, decimals, ratios and percentages, make sure you work out any fractions of an amount that you can see, remembering to divide by the bottom and times by the top for a fraction of an amount, writing it all down really clearly. You can then work out a percentage of an amount using the methods that we've already discussed. And once you've got all your information, you can then find out anything that's missing. But the important part in these questions is to work out anything you can, going through each line step by step and just making sure that you don't leave it blank. So for this, we've also got sharing in a ratio, dividing by the total and sharing it out, and then just making sure that we answer the question. So this one asks for the amount of lemon cakes, so we just need to make sure we actually answer that and don't just leave all the working all over the page. If you have ratios on a line, these can be pretty tricky. Remember, something like 5 times the length is the ratio 5:1, or 2 times the length would be the ratio 2:1. You can then go about sharing that out in a ratio and applying it to whatever diagram. And of course, if you are not given a diagram and just words, you would have to then draw that yourself. So make sure in any of these questions you also draw a diagram. If you have to write a fraction from a ratio, remember to add up the total in the ratio. So this one adds up to 7, and it says how many are red as a fraction. Well, 3 of them are red, so that would be 3 out of 7. If you're also asked to write in the form 1 to n, remember that just means that the number in the position where the 1 is needs to turn into 1, so here we'd have to divide by 12, and our other number could be written as a decimal or as a fraction. When looking at recipes, make sure you read it carefully. Here it's a recipe for 16 and we want to get to 24. So if we divide it all by 2, that will give us a recipe for 8. You could then multiply that by 3 to get a recipe for 24. When looking at an exchange rate, remember to read the exchange rate carefully. Here it's £1 to 18.53 rand. So to get from pounds to rand, you times by 18.53. So £850, we times by 18.53, and then we'd know how many rand there are. Here it says how many notes can be bought, so if we divide by 200 here, we would know that that is 78.75, but of course that's only 78. If you have to convert units, remember centimetres to millimetres, millimetres to litres, and kilograms to grams. So they are your 3 conversions. You can then use that, so timesing by 10 to turn centimetres to millimetres, or in reverse the other way, dividing by 1,000 to turn millilitres to litres, or reversing it the other way, or timesing by 1,000 to turn kilograms to grams, or of course reversing the other way. If you have to convert area or volume units, remember that to convert the length to the area, you square the conversion, and to convert volume, you cube the conversion. So here, to get from 37 centimetres to millimetres, we times by 10 cubed, which is just timesing by 1,000. If you have to do compound interest, with this question here, you would normally use a multiplier. So read the question carefully, make sure you read whether it's asking for the total or the amount of interest, and then make sure that you write down your multiplier method, remembering 1.5% would be 1.015, which we just get from the decimal by adding the decimal percentage onto 1. And there we go, that'll do all the working out for you. You then need to round that to the nearest penny, because we are looking at money, and our monetary system only goes to those 2 decimal places, and if you need the interest, take away the original amount. If you are looking at a method, looking at increasing and decreasing, remember the most obvious error there is that people will put 1.3 for 3%, but that's 30%. It should have been 1.03. With a decrease, you take that percentage away from 100, so that should be 0.97 for a decrease of 3%. When you have these horrible questions with ratios and amounts, make sure that you test the ratio really carefully. So write the ratio out, which is 5 to 2. In this particular question, it says we have an option of having 300 ml of orange juice, which would be timesing them both by 60. The other option in this question, we could have had 200 ml of lemonade, but that goes over the amount of orange juice. So if you're given multiple options, test them both, see which one works, and then just read the question. This one wanted us to say the total. Read any second parts to the question carefully, as they're normally just using a bit of logic. If you have to do inverse proportion, remember this is the one that's slightly different. So in order to find one tap or one worker, you would have to multiply to get that amount. You can then divide it back down when you increase the amount of either taps or workers or whatever the question's about, but we assume that they are all running at the same rate, and that's our assumption. With a distance time graph, you need to read the scales very carefully. So for this one, how many minutes did they stay? Read it very carefully from the bottom and convert that into your time amount. For this one, it was 45 minutes. You may also be asked about average speed. So remember, speed is distance over time, or as a non-calculator method, we can write this down. So this was 25 kilometers in 30 minutes. So speed we want to be 60 minutes. So have a look at how you can convert that to 60 minutes if you are doing this non-calculator. When you have to do speed, distance and time, you may have multiple journeys or multiple bits to draw. Write down your speed, distance, time formula and use a two-way table to help you to organise all the information. Put all the pieces of information from the question into your two-way table, and then also think about different times. If you have something like 75 minutes, you will need to convert that to hours by dividing it by 60. You can then put that into your table and go about working out any missing pieces. So for time, it's distance over speed. For speed, it's distance over time. And when you have a table like this, you need to get the total distance and the total time in order to work out the overall average speed, which we can then do as normal by doing speed is distance over time. You may also have to do this with mass, density and volume. So if you have multiple things that are getting mixed together, write down your density, mass, volume formula. If you do have ones like this, you can again use a two-way table, and again you want to write down anything from the question into your two-way table so that we can actually go about using the formula. From here you can work out any missing pieces. So for the mass, we would do density times volume. We want to get the overall mass and the overall volume in order to work out the overall density of any mixtures. So here we might also be asked to round our answer, so make sure you round that right at the end. If you have pressure, force and area, you'll be given the formula, so just read the question carefully, plug the numbers in. This one actually asked us about a change. This was quite a complicated one. It said if they both increase by 10, how would that change? Now, would it be a 20% change? So for here, we just had to work out 20% of the original and compare it to the new one, and just obviously make a statement to say whether it's correct or not. Okay, moving on to geometry. When looking at angles in triangles or any of these shapes, we need to remember that angles in a triangle add up to 180, and also that base angles in an isosceles are equal. So look for those little lines and make sure you identify the base angles that are underneath the lines, and quite often the isosceles triangles tend to be tilted on their side. Remember all your rules, like angles on a straight line adding up to 180 and angles in a triangle totaling 180 as well, and then answer the question. You may be asked to give reasons, so if you have special quadrilaterals as well, make sure you identify vertically opposite angles as your reason, and you may then be asked to find anything else like angles on a straight line within these as well. A kite is a good one, where the two angles on the wings are equal, and not forgetting that angles in a quadrilateral add up to 360 as well. So answer the question, write your reasons really nice and carefully, labelling the diagram. When you start to look at area and perimeter, make sure you know the formulas for the area of a triangle. That's base times height divided by 2. You can then read any questions and compare them. The area of a rectangle is base times height or length times width. This one here says the area of one was 6 times the size of the other, so we could multiply it by 6 and then divide to find it backwards. With angles in parallel lines, you need to know all your reasoning very well. So alternate angles are equal, corresponding angles are equal, two really important ones. Not forgetting angles in a straight line, angles in a triangle, and all of those important angle methods along the way as well. And make sure that you label all of those reasons around the diagram, particularly when it says give a reason for each stage of your working. For polygons, remember all of the exterior angles of a polygon add up to 360. That fact can help you find the amount of sides. And if you're finding interior angles, you may have a regular or an irregular polygon. No matter what, you want to find the sum of the angles, so take away 2 from the amount of sides and times by 180. If it was regular, you would divide by the amount of sides, but if not, we just have the total. This one again says one angle is twice the size of the other. You could use algebra, or you could write that as a ratio 2 to 1, and then just split whatever's left over between those two using a ratio if you have to. For this one, it did ask us to work out the size of the larger angle, so we have to sub it back in. When you're writing a plan or drawing a plan and elevation, you need to read the scale very carefully. So here it says 2 centimetres was equivalent to a metre, so for the height on the left it was 2 metres high, and the little part was half a metre high, so 1 square up. When you're looking at area of a circle, you may be asked to actually calculate that in a calculator, or it might be an estimation question. Either way, you need to know the formula pi r squared. So substituting the radius in, this one was an estimation question, so we're using pi is equal to 3 and rounding all of our numbers to one significant figure. So read the question very carefully and make sure if it says to estimate that you actually state that, and why it might be an under or overestimate. If you are looking at semicircles and you are looking at other parts like the circumference, remember that circumference is pi times diameter. This was asking us to look at the perimeter all the way around, so we halved the circumference, and then we'd also, for the perimeter, add on that length of 50. So don't forget, with the perimeter of a semicircle you also have that diameter to add on. For here it was looking at the amount of money it would cost, so we just multiplied the total amount by the cost of the fence, and then we worked out the amount of money for the day's work. When you're looking at things like cylinders, you need to know your formulas for volume and surface area. Surface area is a really nasty one. You've got pi r squared for the top and pi times diameter times the height for the bit wrapped around the outside. So you can work those out individually, getting the areas of the circles and the areas of the curved part and finding the total surface area. This one was a functional question that looked at 3 of those tanks, so we would times it by 3, and it said that we had some paint that had to be covering them. So 7 tins of paint at 5 metres squared per tin. We then just made a comparison, so some slightly trickier questions with these. If you're looking at volume and surface area of cubes and cuboids, just remember, work out the surface area of whatever you can. You've got 3 different surfaces on a cuboid. The total will need to be doubled when you are doing it using this method, as there are 2 of each surface. This question said the surface area was the same, so the surface area of a cube, you just take the surface area, divide it by 6 for each of the surfaces, and you can square root that to find the length of each of the squares. Volume, you just multiply all 3 sides together. This one we were making a comparison. If you have a triangular prism, again you just need the area of the cross section and multiply it by the length. This particular one on the screen though, you can see that we don't have the base, so we'd have to use Pythagoras for this one. If you do have to use Pythagoras, just be careful if it's an add or subtract, but then normally you just find the area of the cross section, multiply it by the length. This was area of a triangle, and then multiplied by 18, which gave us the volume of this triangular prism, and then rounding it to 3 significant figures, and not forgetting units with your answer. You may have some slightly more complex questions where you are looking at unit conversions. This one was the volume of a cuboid, but it was talking about millilitres. 1 centimetre cubed is equal to 1 millilitre. So once we got the volume, multiplying them together, it wanted it to be 2/3 full. So working out a fraction of an amount, dividing by 3 and timesing by 2, told us there was 2,280 millilitres. From there, wanted to know how many cups could be filled, so dividing by the amount in each cup told us 8.29, which we would have to round up to 8 as only 8 can be filled. If you have a look at a sphere, you will be given the formula, so identify the radius first, and then just plug that into the formula on your calculator. So this was 4/3 times pi times r cubed, so just make sure you know where that cubed button is on your calculator for when you have to use these, and again, round your numbers to however you've been asked. With transformations, you need to know how to describe a reflection. So this one here, this is a reflection, and you need to find that reflection line. So make sure you have a look where is in the middle of both shapes, identify that line, and this particular one here is the y-axis, although that can be described as x equals 0, but if it's in the axes, I'd say it's the axes. With a rotation, you can use tracing paper, but as well, you can actually figure this out without tracing paper. Important part, we need to say that it's been rotated. I would stick the tracing paper over the top and then just stick my pencil onto one of the coordinates, spinning the paper around by how many degrees I can see it is, just to find that rotation point. But this one here, the point can be found with a 180-degree rotation by joining up the similar sides. With a translation, you will be given a vector. This one has asked us to rotate it first. So again, I'd be using tracing paper to do that. Stick your tracing paper over the top, spin it round and trace it in underneath. For the vector on this translation though, it said it wants us to move it -1, -3, which is 1 left and 3 down. So move one of the vertices and make sure you redraw it in from that vertice. When you have bearings, you're going to need your protractor and most likely your ruler if it has a scale. So for this one, we measured the distance. It comes out as 4.5 centimetres, and it says on the scale that 1 centimetre is 0.5 kilometres, so we can multiply that distance. When you are measuring the angle, get your protractor, measure it out really carefully. Remember your congruent triangles means exactly the same. So if you're looking for two that are congruent, fill in everything that you can with any missing angles, and then just see if you can find anything that matches them up. Here I've identified which angle was opposite the 10, and you can see that there was only two where the angle of 80 was opposite the 10. So congruence was A and D. If you're looking at column vectors and adding them together, just make sure you write them out. Remember, they are not fractions. You can multiply a vector, just multiply the top and the bottom. So this one, 2 and 3, is 6, and 2 and minus 2 was -2, and then just adding the top or subtracting the tops and being careful with any positive and negative values. If you have to label them, you just need to pick 2 points, make sure that you can do that. This was going left by 1 and up by 4, and then join them up and label that vector with the arrow. Okay, on to probability. When you are writing a probability, just make sure you read the question. Remember, we usually always try and write them as a fraction. Here it was about the probability of not winning a raffle, so we found how many raffle tickets she didn't buy and just put that over the total. And we don't need to simplify with probability. If you are asked to label a probability line or a probability scale, remember on the left is impossible at 0 and on the right at certain is 1. Closer to 0 you have events that are unlikely, closer to 1 you have events that are likely. With a frequency tree, just make sure you put all of the numbers from the question into the frequency tree, and as you go along finding any of the missing pieces. So where it said there were 48 women, we knew that there must be 32 men as it was out of 80. So just go through really carefully, figuring out any missing numbers, double check that they all add up, and if you're asked about a probability, read the question carefully. This said they're going to pick one of the people that likes coffee, so it's only out of 61, and 37 of them were women. If you have some information looking like this, you can use a frequency tree as well, but I tend to use a two-way table. So draw a nice table and start filling in any of the missing numbers from the question. Once you've done that, you can go through the rows and the columns and finding any missing numbers where there is only one missing. Once you've completed the table, you can answer the question. This one said find the number of students who walk to school, so just answer that carefully. With a probability tree, each pair of branches have to add up to 1. So look at the denominators and make sure that each other branch balances that to make it add up to that denominator. When you go across a tree, you will multiply the two fractions and you don't need to simplify. If you have decimals on the tree, you take the same process. Again, they have to add up to 1. This was asking us about some mistakes in the probability tree. So here they had to add up to 1, and over there they were swapped around, and that's not how probability trees work. They have to stay the same.